this question is tricky and the answer doesn't help you very much, right? You look at it and you're like, this is no help at all, right? So classic approach is to take the question and to boil it down into something which is more handleable. So actually the question is very well crafted because it is numerically simple, but it's just hard enough that you can't do it exhaustively, right? So what you do is you take a question like it that you can do exhaustively and you see how the logic works out. So let me give you an example. Okay. Instead of going up to 4, let's just go up to 3. Okay. So the question becomes, I'm going to use the digits 1 to 3. Okay. I'm tackling just 3 because it's much more handleable. Yeah, exactly. You can list them, which is exactly the point. And when you list things, you can see patterns. That's why it's so useful. Okay. I'm going to use those numbers. There's not many. And I'm going to see what happens, okay? I'm going to add them all up and that's what I'm looking for, the total sum, okay? So let's just quickly write them all out. Now, even before I start to write them out, you can actually tell me already how many possibilities, how many arrangements are there?
Wait.
There are 3 alternatives. It's 3, which is also 3 factorial, which is 6, okay? And I will write them out for you. They're really easy to write. 3, there you go, 6 options, done, okay? And as you said, because you can list them, now you can start to spot some patterns. Okay? So here's the first thing I noticed. Okay? There are 3 factorial permutations. Okay? So if I were to scale up, if I was going to do the digits 1 to 5, for instance, there'd be 5 factorial permutations. No problem. Okay? Now let's start to think about how can I add this up in a systematic way, in a logical way. Okay? Well, let's just have a look at it column by column. I'm going to deal with them column by column because I have to treat the columns differently. Okay. So for instance, let's have a look at all of the 1s in the units column. Okay. Now I see 1, 2 of them. Now here's my question when I see 2 of them. Why are there 2? And in what situations would the number of 1s in this column change? Okay. Now here's the first thing I noticed. There are 3 factorial in total. Right? Numbers here to add up. But I'm only interested in the 1s. That's, out of 3 alternatives, it's 1/3 of the numbers. Can you see that? Yeah. 1/3 of these 3 factorial numbers in this column are 1s. Okay? So therefore, how many 1s are in this column? And the answer is 3 factorial on 3. It's 1/3 of them. Right? If I said to you, I have 2,000 students in the school. Right? And I want to pick out, no, that's a bad example, sorry. I have 52 cards in a deck, okay? And I want to pick out, now how many how many hearts are there? How many hearts are there? And the answer is, it's not just 13, there are 4 suits, right? There are 4 suits, so that means exactly 1/4 of my cards will be hearts, right? So if there are 4 alternatives, then I'll divide by 4. Right? And there are 3 alternatives here, right? So how many of these 1, 2, 3, 4, 5, 6 numbers are there that will be 1s? And the answer is divide by 3. Just like I divided by 4 to get the number of hearts, I'm going to divide by 3. If you like, my 1s are my suits, right? I've got 3 suits to choose from.
And then 3 factorial.
And there are 3 factorial cards in my deck, right? Now, 3 factorial on 3, that's actually 2 factorial, isn't it? Okay. So, when I add up all of the 1s in this column, right, the sum of all of the 1s in the units column, right, it's going to be 2 factorial times, now each 1 is worth 1, right, and they're units, so it's 1. Okay, so there you go. Now the reason why, that looks a bit silly, but when I go to the next one, you see why it's important, right? If I do all the 1s in the 10s column, okay, how many 1s are there in the 10s column? And the answer is exactly the same number, because I'm doing the same thing. I have the same number of permutations to choose from, and the same proportion of them will be 1s. So it's still going to be 2 factorial. Each 1 is still 1, but now they're all worth 10. And then I do it one more time for the hundreds. Right? So there's still 2 factorial of them. There's still 1, and they're now worth all 100. So if I was to work out now what's the sum of all of the 1s in my picture, right? It's going to be, I'll take out a factor of 2 factorial, I'll take out a factor of 1, and then I can add up these guys, which is 111. Okay. So if that's what all of the 1s are, then I can work out what all of the 2s are. How many 2s are there as I go through each column? And the answer is still 2 factorial. They're now worth 2 each. But when I add up all the units, 10s, and 100s, I'll end up with 111. And I'll do the same with the 3s. There's still 2 factorial. Now they're worth 3. You still got 111. So now I factorize one more time to get the sum of everything. 2 factorial. 100s, 10s, units. And then I say, well, I have 1 of them here, 2 of them here, 3 of them there. And so now you see, from a problem that is manageable, you can scale up from there. Okay? And then you could scale up to however much you wanted. But you now see why that's a 2. It feels like it should be a 3, but it's not, right? And you now, like this, I think that one makes more sense. Once you start adding them up, you see where it comes from. And then you see why that's not just an arbitrary thing. I'm pooling things together that form a pattern.